In this video, you're going to learn how to do some basic geometry constructions involving a compass and a straight edge. You can use a ruler or any type of straight edge. And we're going to go through about 14 different constructions. So let's start off with how do you copy an angle? And if you want to jump to any particular type of construction, look in the description and I'll put timestamps for all these different constructions. So when you copy an angle, what you want to do is you want to start off by drawing a ray. And let's go ahead and draw that down here. And I tend to draw these rays and these arcs a little bit larger or longer than I think that I need. This way you don't have to go back and redo it later. So if we go up to our first angle here, what you're going to want to do is you're going to want to put the point of the compass right here at the vertex, and you're going to want to open up the compass a certain amount, and what you're going to do is you're going to draw an arc such that it crosses both sides of the angle, okay, both rays. You're going to take that compass with that same level of opening, you're going to put the point on the vertex of that ray, and you're going to draw that same arc. Okay, and again, like I said, you want to make it a little bit longer than you think that you need. Now what you're going to do is you're going to go over to the first angle, and you're going to use the compass like a measuring tool. You're going to want to open it up in such a way that you're measuring from this point of intersection to this point of intersection. So let's see if we can do that. And I would just put a little arc here just to show that you measured that on the first angle, and then go down here to the second angle and go ahead and make that arc. Now what you can do is you can draw a ray from this point and this intersection, and that's going to be copying the angle. So let's go ahead and do that. And that's it. You've effectively copied that angle. So let's take a look at the next construction. Let's take a look at how to draw a perpendicular bisector. So when you draw a perpendicular bisector, you're going to have a segment, and what you're going to want to do is you're going to want to open up your compass, and you want to make sure you open it up a little bit more than half the length of this segment. So you just want to make sure it's not less than half, so a little bit more than half is good. And then what you can do is you can put an arc above the segment and an arc below the segment. Or what some students like to do is just draw one continuous arc like so. Then what you're going to want to do is you're going to want to go to this other end point, and you're going to want to draw using that same arc. Okay, the compass is open the same amount. You're just going to want to draw another continuous arc, or you can do two separate arcs, one above and one below the segment. Then all you have to do is use these 2 points of intersection right here and right here to draw your perpendicular bisector. So let's go ahead and do that. And you can see that this is a right angle, perpendicular, and you can also see that it's bisecting or cutting this segment in half. Now we're going to talk about how to copy a segment. So when you copy a segment, this is kind of an easy construction. All you want to do is start by drawing a ray. And again, I make it a little bit longer than I think I'm going to need. And then what you do is you use your compass basically as a measuring tool. So what you're going to do is go to the segment that you want to copy, and you're going to want to open it up to the length from one endpoint to the other endpoint. So I would just make a little arc here just to show that you measured that length. Then take that compass over to your ray and put the point at the endpoint here, and then draw an arc like that, and you've effectively copied that segment. So you can see that this length is the same as this length, and you got it. In this next construction, we're going to construct a perpendicular from a point to a line. So remember, the shortest distance from a point to a line is going to be at a right angle or perpendicular. So to do this construction, what you want to do is take your compass, go ahead and put the point right here at the point of the compass right at the point, and then you're going to want to open your compass to a certain length so that it crosses the line at 2 different points. So if it's too short, it's not going to cross, or if it's just right, you want to make sure that it's just going to cross at 2 points. So basically we're going to go ahead and draw one continuous arc. You can do 2 separate arcs if you want, but I like to just do one continuous arc like that. And so then what you're going to do is you're going to use these 2 points right here, these 2 points of intersection, to draw 2 more arcs. So what I'm going to do is I'm just going to use this point here. I'm going to open up the compass a little bit more. Okay, and I'm going to draw an arc. I'm going to go to this other point here on the line, draw an arc, and now what we can do is we can draw a line through this point and this point of intersection here, and that's going to be our perpendicular from the point to the line. So let's go ahead and do that. And that's it. You can see that that's going to be a right angle. For this next construction, we're going to talk about how to construct a line through a point parallel to a given line. So say this is line L, say this is point P, and what we want to do is we want to draw a line through this point parallel to line L. So what we're going to do is we're going to draw a point anywhere along line L. I'm just going to draw a point right here, and what we're going to do is we're going to draw a line through those 2 points. Now you could draw it as a ray if you want. I'll draw it as a ray here. Okay, and so then what you're going to want to do is we're going to do just like we did earlier where we copied an angle. So I'm going to copy this angle right here up to right here, and we're making use of the corresponding angles converse theorem if you learned that. But if not, here's what you're going to do. You're going to go over here to this vertex, and I would draw an arc. And if you have any trouble with using a compass or a straight edge, check out my video about how to use a compass. That'll help you with some of the techniques here, because sometimes when students do this, their compass opens up on them, or the compass skips, or there's all kinds of different issues students have, but as far as just using these tools. But here what you can see is I copied this arc over to here, so all we're going to do is copy this angle. And so what I'm going to do now is I'm going to use the compass as a measuring tool to see how open this angle is. So I'm going to measure this distance right here, and I'm going to carry that over to here, draw an arc, and now all we have to do is draw a line through this point and then this point of intersection right here. So let's go ahead and do that. And you can see this line M, we'll call it, is parallel to line L, and again that's because of the converse of the corresponding angles theorem. Okay, for our next construction, we're going to talk about how to bisect an angle. So this is the angle here that we want to bisect or cut in half. And so what you're going to want to do here is you're going to want to take the point of your compass, put it at the vertex of the angle, open up your compass, and then draw an arc such that it intersects both sides of the angle. Then we're going to use these 2 points, right here and here, to draw 2 more arcs. So I'm going to draw an arc like so. Go to the other point of intersection on the side of the angle, draw another arc like so. And now all we have to do is draw a ray through the vertex of the angle and then this point of intersection here, and that's going to effectively bisect the angle. So let's go ahead and do that. And that's it. You can see that this angle here and this angle here are congruent to one another. For this next construction, we're going to talk about how to draw a square inscribed inside of a circle. So in order to do this construction, what we're going to do is we're going to start off by drawing a diameter. Now remember, a diameter is a chord that goes through the center of the circle. So just go ahead and locate the center of your circle, draw a chord, okay, such that it goes through that center point. And then what we're going to do now is we're going to find the perpendicular bisector of this diameter. So in order to find the perpendicular bisector, we're going to use the endpoints of the diameter. I'm going to open up the compass a little bit more than halfway, and we're going to draw an arc above and below that diameter, or what you can do is just draw one continuous arc. So that's what I'll do here. Go to the other endpoint of the diameter and go ahead and draw an arc above and below the diameter, or you can draw one continuous arc. And now what we're going to do is we're going to go ahead and draw that perpendicular bisector using these 2 points of intersection. So let's go ahead and do that. And you can see it's going to cross the circle at these 2 points right here and here. So now all we have to do is connect these 4 points, and we're going to have a square that's inscribed inside of a circle. Now remember, inscribed, scribe means to write or draw. In means like it's on the inside or the interior of the circle. Whereas circumscribed, like in this case the circle is circumscribed, meaning circum means like around or about the square. So let's go ahead and draw that. And you can see it, there we go, our square is inscribed, meaning the vertices lie right on the circle and it's on the inside of the circle. For this next construction, we're going to talk about how to circumscribe a circle about a triangle. So in order to do this construction, we're going to need to construct a minimum of 2 perpendicular bisectors of the sides of this triangle. Now I might end up drawing all 3. We'll see how this goes. But let's go ahead and start with this line segment here, okay, the side of the triangle. We're going to draw a perpendicular bisector, which we did earlier in this video. So what we're doing is just kind of stacking concepts here. So remember, open up that compass a little bit more than halfway. Okay, and then if I go to the other endpoint of the side of the triangle and draw another arc. And what we're going to do now is we're going to use those 2 points of intersection where those 2 arcs cross, and that's going to be our perpendicular bisector. Now what you're going to want to do is, again, like I've mentioned earlier, you're going to want to draw these a little bit longer than you think you need, because it really saves you some time and aggravation with having to go back later and trying to extend some of those lines. So that's our first perpendicular bisector. I'll just indicate that here. So it's bisecting that side. Let's go to this other side over here now and draw the perpendicular bisector. So what I'm going to do is, again, I'm going to open up the compass a little bit more than halfway, and I'm going to draw one continuous arc such that it goes above and below that side of the triangle. Go to the other end point and go ahead and draw an arc, that same arc. Okay, and now what we're going to do is we're going to use those 2 points of intersection, which are, let's see, where is that? Right here and right here, to draw our perpendicular bisector. So you can see that's at a right angle and it's cutting this segment over here in half. And let's just do one more. Let's go ahead and use this third side here that we haven't worked with yet. Let's go ahead and draw the perpendicular bisector of that one. It's getting a little bit chaotic here, as you can see, so because of all the lines, but see if you can follow this. I'm going to draw one continuous arc such that it goes above and below that. It goes above and below that line, and then go to the other end point and draw another continuous arc such it goes above and below that line. And then now when we go and draw the perpendicular bisector here, let's see, that's right about here. You can see that's perpendicular and it's bisecting that side. And what we're looking for here now is, where do all these 3 perpendicular bisectors cross? Well, let's see, it looks like here's one, here's one, here's one. They're roughly crossing right about here. Okay, so that point is called our circumcenter. That's where the 3 perpendicular bisectors cross. And so now what we're going to do is we're going to take our compass, put the point at that circumcenter that we just mentioned, and what we're going to do is we're going to open up the compass so that it just barely reaches to one of the vertices. But what you'll notice, it's going to be the same distance to all 3 vertices. Okay, so let's go ahead and draw now a circle around the triangle. So we're circumscribing, okay, or drawing a circle around the triangle such that the vertices lie right on the circle. Now you can see my drawing was pretty good. You can see this is touching here, this is touching here, this is touching here. Now a question your teacher might ask you in these types of problems is, what do you know about this length or this length or this length? Well, you can see these are the radii of the circle, so they're all going to be congruent. They're all going to be the same length. So that's how you circumscribe a circle about a triangle. Okay, for our next construction, we're going to talk about how to inscribe a circle inside of a triangle. So again, stacking concepts. We talked about this earlier in this video about how to bisect an angle. We're going to find the 3 angle bisectors of this triangle. So what we're going to do is we're going to go to this vertex here. We're going to draw an arc. And then we're going to use those 2 points of intersection to draw 2 more arcs. I just keep the compass at the same opening. And then we're going to go ahead and draw a line, or I should say a ray, from this vertex through this point of intersection. And I'll just draw it to the other side of the triangle. So you can see that's bisecting that angle, or cutting that angle in half. We're going to go over here to this other angle and we're going to bisect that angle. So let's go ahead and draw an arc. Okay, and then we're going to use those 2 points of intersection and we're going to draw 2 more arcs. So like that and like that. And then we're going to use that point of intersection and the vertex, excuse me, to draw a ray. So let's go ahead and do that. So you can see that this angle is being bisected or cut in half. Now you could do that again on the third angle, excuse me, and you'll find out that they're going to all cross at the same point here. And this point here is what's called the incenter of the triangle. Now, what's interesting about the incenter, that means that's going to be the center of a circle that can be inscribed inside of the triangle. But what we need to do now is we need to find the perpendicular distance from this point to this side, or this point to this side, or this point to this side. Doesn't matter which one. Let's just go ahead and do, let's say, from this point to this side. So we talked about this earlier in this video, how to draw a perpendicular from a point to a line. You're going to want to open up your compass so that when you draw an arc, it crosses the side of that triangle at 2 points. Okay, then you're going to use these 2 points here to draw 2 more arcs, and I just would leave the compass open at the same amount of opening there for both of these. Okay, and then all we have to do now is draw a line from this point to this point of intersection right here. Okay, so let's go ahead and do that. And so you can see what we've drawn is this is a perpendicular, which means it's the shortest distance from this point to this side of the triangle. Now we're going to treat that as the radius of our circle. So we put the point of the compass at this in-center point right here. We're going to open up the compass so that it just barely touches at where we drew that perpendicular to the side of the triangle. And that's going to be the radius of our circle. So now what we're going to do is we're going to inscribe or draw our circle inside of our triangle. Okay, so let's see how we did. So you can see that it just barely touches the side of the triangle. So the sides of the triangle are basically like tangents to the circle. Now here you can see I went a little bit over, and that's because some of my drawings might have been not exactly perfect, some of my construction, so that's why I went a little bit over, but if you take your time, it should be exact. And then what your teacher will oftentimes ask you is, what do you know about this perpendicular distance, and this perpendicular distance, and this perpendicular distance? Well, they're all going to be congruent because they're the radii of this circle. And so if you know this length, you're going to know these other 2 lengths. But again, this point is the incenter. It's where the 3 angle bisectors cross, and then you can inscribe the circle inside of the triangle. Okay, for this next construction, we're going to talk about how to inscribe a regular hexagon inside of a circle. So how do we do this construction? Well, what you want to do is you're going to start with a circle, and what I would do is I'd open up your compass so that you go from the center of the circle to a point on the circle. That's going to be your radius. Now with that same level of opening, you're going to take your point of your compass and you're going to put it at that point on the circle, and you're going to make arcs working your way around the circle. So I'm just rotating the circle, putting the point at the next point of intersection, draw another arc, just keeping that compass open the same distance, working your way around the circle, drawing those congruent arcs. Okay, and so now what you want to do is you want to connect each of these points, and that's going to form a regular hexagon. So let's go ahead and do that. See what we get here. It should be a perfect hexagon, a regular hexagon, where all the sides are congruent, all the angles are congruent. Let's see how this is looking here. Now you can also do this exact same construction and create an equilateral triangle, an equilateral, equiangular, like a regular triangle. And the way that you would do that is you would use every other point. So I'd skip one, go to the next one, skip one, go to the next one, skip one, go to the next one. So if we do that, we can inscribe an equilateral, equiangular triangle inside of this circle. Sometimes you'll do that construction instead of the hexagon one in your class. Let's see what that looks like. So some pretty interesting designs there. Now let's take a look at another construction. Okay, for this construction, we did one in the last construction with an equilateral triangle, but this is a little bit different. If we want to construct an equilateral triangle with this given side length right here, how would you do that? Well, what you do is you use your compass again like a measuring tool. You're going to want to open it up so that it just barely reaches to the other endpoint like that. And I would just draw an arc to show that you measured that. Then what you're going to want to do is you're going to want to draw an arc like this. And again, remember how I tend to draw them a little bit longer than I think I need. Okay, and then go to the other end point with that same level of opening of your compass, draw another arc, And then what you can do, you see this point right here, we're going to connect these endpoints of the original line segment, the original side of the triangle, and that's going to form an equilateral, equiangular triangle, and you got it. Okay, in this next construction, we're going to talk about how to copy an entire triangle using the side angle side. So how do we do that? Well, the first thing we want to do is we want to draw a ray. And again, what I would do is I would draw that ray a little bit longer than you think you need. And this endpoint here, let's call that A prime. And so what we're going to do is we're going to start off by copying this side of the triangle AC onto this ray. And we talked about this a little bit earlier in this video about how to copy a segment. You just use the compass as a measuring tool. You open it up so it just barely reaches this point here, point C, and I just draw a little arc to show I measured that, and then go ahead and carry that over here onto the ray. And so then where that intersection is right here, this is going to be our point C prime, and you can see that A prime C prime is congruent to AC. Okay, now what we're going to do is we're going to copy this angle A onto this point here, A prime. So what we're going to do is, we talked about this earlier as well, how to copy an angle. You're going to use your compass to draw an arc such that it crosses both sides of the angle. And we're going to use the compass with that same level of opening. Go ahead and carry that over to this ray. Okay, and again, I would draw that arc a little bit longer than you think you need. Then what you're going to do is you're going to go to the original angle here, A, and we're going to measure from here to here. We're going to use the compass as a measuring tool, and I'm just going to make a little arc right here, and I'm going to carry that over. I'm going to make an arc right here. Now all I have to do is draw a ray through A prime in that point of intersection, and again, I would make it a little bit longer than you think you need, like that. Just draw a ray. And so now you can see that this angle and this angle are congruent. So that's our side angle. And now we just have to do one more side. So we're going to copy this segment AB onto this ray. So again, we talked about this earlier, how to copy a segment. You're just going to use the compass as a measuring tool. So you open that up. Okay, a little bit more, right about there. And you're going to carry that over here. And so now you can see, here's your B prime. So you can see that AB, segment AB, is congruent to segment A prime B prime. Now if we connect these together, what do we have here? We've got it. So you can see that this triangle is congruent to this triangle by side angle side, and you got it. Okay, for this next construction, we're going to talk about how to copy a triangle using side, side, side. So remember, if three sides in one triangle are congruent to three sides in another triangle, then that means that the two triangles are congruent. So I'm going to start off by just drawing a ray. And again, remember, I always want to draw that ray a little bit longer than we think that we need. And what we're going to do is we're going to copy this segment here, AB, onto that ray. So we talked about how to copy a segment. We're just going to open up the compass, use it as a measuring tool, so it just barely reaches B here. Let's see if I can get that a little bit more accurate. So basically like that. We come over here. Okay, and so now you can see if this is our A prime, and this over here would be our B prime, and we know that these two segments are congruent. Okay, so now what do we need to do? Now we need to copy another side. So how can we copy another side? Well, let's go ahead and look at the length of BC here. So I'm going to use the compass again as a measuring tool. So put the point at one of the endpoints of the side, put your pen or pencil at the other endpoint. And what we're going to do is we're going to carry that over to B prime here. And what I'm going to do is I'm going to draw an arc bigger than I need. Okay, it's okay to have it bigger than you need. You can always go back and erase some of the extra if it's too big. And then what we're going to do now is we're going to also look at the length of AC here. Okay, AC. And so I'm going to use the compass again as a measuring tool. Okay, so I'm going to open that up right here, AC, and I'm going to go over here to A prime, and I'm going to draw an arc. Now you can see those arcs are intersecting right here at this point. So what we can do now is we can draw the other two sides of our triangle. So we've got from here to here, and also from here to here. And that's it. So you can see that this is the location of C prime. So you can see that BC and B prime C prime are congruent, AC and A prime C prime are congruent, and we proved the two triangles congruent by side, 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 side. Okay, before we do this last construction of copying a triangle using the angle side angle, if you want to see like maybe where I got some of these tools from, I'll put some links, some Amazon links in the description below, so you can check those out if you need to get a hold of any of these tools that I'm using here. But let's dive into this last example here. So what you would do to copy the triangle is you would start by drawing a ray. And again, remember our rule for drawing rays and arcs, try to draw them a little bit longer than you need. Okay, you'll thank yourself later. And so here's your ray, and let's just call this point W prime. Okay, so that's going to be our new point W. Now to do angle side angle, let's start off by copying this angle W onto W prime. So how do we do that? Well, we talked about this earlier in this video. We know how to copy an angle. We start by drawing an arc such that it intersects both sides of the angle. We go ahead and carry that over here to W prime and make that a little bit longer than we think we need. A little bit further like that. Okay, now what we're going to do is we're going to measure how open this angle is. So we're going to measure the distance from here to here. And I would just mark that with a little arc to show that you measured that. Same thing over here. And now all we have to do is draw a ray from W prime through that point of intersection. Again, drawing it a little bit longer than you think that you might need. Okay, like that. And so now you can see that this angle W and W prime, they're congruent to one another. Okay, so that's the angle part. Now let's do the side. So let's look at the side WY. So WY, to copy a segment, we talked about that earlier in this video, we just have to use the compass as a measuring tool, open it up so that it barely reaches the other end point, draw an arc to show that you measured that, carry that over to this ray. Okay, and that's going to be the location of Y prime. Okay, so our new Y. So now you can see that this segment is congruent to this segment, so that's the side. Now we have to show the other angle, so angle side angle. So we have to copy angle Y over onto Y prime. So we know how to copy an angle. We just start by drawing an arc such that it intersects both sides of the angle. Let's go ahead and draw that over here. Okay, like so. A bit longer than you think you need. And we're going to measure how open this is. So we're going to measure from here to here. Carry that over here. Okay. And now all we have to do is draw a ray from Y prime through this point of intersection. And you can see this is going to be our new X prime. So we copied that angle. So you can see we've got it. We've got our angle, side angle, and that proves that both these triangles are congruent to each other, and you got it. So great job. If you want to see some more videos that I did talking about constructions, I'll put a link to a playlist of my geometry constructions on the screen now. And if you want to check out those, I'll see you over in those videos. Talk to you soon.